Hello, class. Today we're going to be talking about exponents and expressions. So what I have written here is 5 squared. And what we call this 5 is going to be the base, whereas the 2 is going to be the exponent. And this is great to know the name of 5 squared and its individual parts. But what does this mean? So 5 squared is just another way of writing 5 times 5. In fact, if you type 5 squared into your calculator, you should get 25. So what does this mean? Basically, sometimes you don't want to write 5 times 5, especially if you do 5 times 5 times 5, or 5 cubed. So bases and exponents are used to basically shorten up writing multiple multiplications of the same number. So likely we can write 3 to the 4th, and that's going to be 3 times 3 times 3 times 3. And so that's all that an exponent is. It's just a way of writing multiple multiplications. Now, we're going to be using this, as well as grouping symbols, in order to understand how to solve and create expressions. So grouping symbols are things like parentheses. You can do braces, like this, like we used for a set, and you can do brackets. And we're going to use all of these different things in order to create the order of operations, or PIMDAS. Right? And this is something that we reviewed in class on Friday, but I just want to briefly go over it. So parentheses, please do not make fun of my spelling if this is wrong. Parentheses, I have no idea. Exponents, what we just learned. I'll just shorten that to x. This is multiplication and division. So x and division. And this is addition and subtraction. So anytime you see an expression, we're going to be using the PIMDAS rules, the orders of operations, in order to tell us how exactly to solve that. So let's pause the video. I'll write out some expressions, and we'll try to solve those together. One quick thing that I forgot to mention before we start talking about expressions is that we need to be doing PIMDAS, sorry, that's an eraser, PIMDAS in the order from left to right. So in an expression, you will read it from left to right, and that's how we're going to apply these PIMDAS rules. We're going to be applying them from the left all the way to the right. So now let's look at expressions. Here are 2 expressions that I've written down, and we are going to use the PIMDAS rules that we just went over in order to solve them. So first we have this expression where we have 6 divided by 3, we have 3 plus 5, and that 5 is squared. So these lines are just to kind of highlight the different operations that are being used. So if we look at our rules, we have PIMDAS, so P parentheses, there are none. So then we move on, so E exponent, okay, we have an exponent. So that means that this equation is going to be 6 divided by 3 plus, we do the exponent, so 5 times 5 is just 25. Okay. Now we go over and we do the second rule. So we had exponent, there's no more exponents, so then we get to multiplication and division, and we see that there is a division right there. So 6 divided by 3. Well, that's just 2, right? 6 divided by 3 is just 2. So then we have 2 plus 25, and this is when we do addition and subtraction. So our answer is 27. So 6 divided by 3 plus 5 squared is 27. Let's move on to the next one. Okay, so here we have 2 multiplication. Well, we have 1 multiplication, we have 1 division, and we have 1 subtraction. So again, looking at our PIMDAS rules, we're going to do the multiplication first, and we're going to do the leftmost multiplication first. So we're going to do 3 times 10, so that's going to be 30. minus, we're going to leave that minus alone, we're not going to do it yet, and now we're going to do the second multiplication slash division, which is 7 divided by 7, which is just 1. Now that we've done that, this is going to equal 29. 30 minus 1 is just 29. And here are our solutions. So I just want to highlight that we could have messed this up multiple times. If we would have done 3 plus 5 squared first, we would have then had 6 divided by 28, which is not going to give us 27. So this is wrong. If we would have done the addition first, we would have gotten that wrong. And similarly, if we would have, say, in the second example, done 10 minus 7, we would have had 3 times 3 divided by 7. And again, we can just simply look, 3 times 3 is 9. 9 divided by 7 is obviously not 29. So again, this is the wrong way to do that. You will get different answers if you do not do the correct operations first. So it is important to remember those PEMDAS rules and apply them from left to right. Now let's talk about evaluating expressions. Okay, here we have two expressions with different variables, x and y. So this right here is called a variable, this x. And what a variable is it's just a stand-in for a number. And the same thing for this y, it's just a stand-in for a number. And so what these stand-ins do is they allow you to plug in whatever input that you want in order to see what you get as an output. So whatever we want x squared to be, or whatever we want x to be, will give us a different output. If x is 1, so if x is 1, then the answer to this expression is 1 squared plus 9, which is 1 times 1 is just 1, and 1 plus 9 is 10. We get 10. But if x is 2, then we get 2 squared plus 9, which is equal to 13. So you can see that different inputs for our x give us out different outputs, or different answers. And this is kind of the point of expressions. They give relationships, and you can put different inputs in to see what kind of outputs you get. Similarly with this y and x expression, the only thing that's different is that you need two different inputs. They can be the same, so y and x can be the same value, and in this case we just get 1 plus 1 divided by 2, which is equal to 2 over 2, which is equal to 1. Or they could be different inputs. So if x is, let's say, minus 1 and y is equal to 3, then we'll get something that looks like minus 1 plus 3 over 2, which is equal to actually the same thing, right? And this is fine. So when you have two inputs, you can have different when you have two variables, you can have different inputs that give you the same answer. And that's okay. That's totally fine with that. Um, yeah, but this is what exponents, or expressions, sorry, this is what expressions allow you to do. Given some input, you'll get some output. Okay, the last thing I am going to touch on is determining whether or not a solution or an input for a variable is a solution to an expression. Okay, here we have an equation. Now, why is an equation different from an expression? Quite simply, it's because it has an equal sign in it. So expressions are just simply, how do I phrase this? Expressions are simply numbers relating to other numbers and variables, and you can get some output from it. Whereas an equation tells you that there is a distinct relationship between two things, two expressions. In this case, one of them is 0 and one of them is x squared minus 4. And these, in this equation, are supposed to always equal each other. So in scenarios where you have equations, you can say x equals 2 is a solution. What does this mean? So a solution is a number or value for the variable that says that this equation is true. And let's test that out. So x equals 2. What is that? So 2 squared minus 4 is equal to 4 minus 4, which is equal to 0. So there it is. This is true. Now, for any other input of x, so let's say x is equal to 3, this is not a solution. And what does that mean? Well, that means that putting x equal to 3 into our equation does not give us it does not prove that this equation is true, or it is a false statement. So 3 squared minus 4 is equal to 9 minus 4, which is equal to 5, which is not equal to 0. So this shows that x equals to 3 is not a solution of this equation. It gives you a result that does not prove that it is true, if that makes sense. I hope it does. And then the last note that I'll make on this is that all you have to do to tell whether something is a solution is quite simply just plug it in. Just whatever value it gives to a variable, plug it into the expression on whatever side and see if it gives you the output of the side without the expression. So look at this as the output you need. And this could be on the right side, it could be on the left side, it doesn't matter. Wherever you see the variable, plug it into here, and then use the other side as the output. And if that output matches what you get from the side with the variable, then it's true, and whatever input you gave is a solution. Now, you will have questions on the homework, and it's important to know how to translate words into, oops, did not mean to erase that, into an equation. And I'll just say this really quickly. There's a chart on page 30 of your textbook. That's very crooked, but there's a chart on page 30 and it tells you all the words that can go with addition, subtraction, multiplication, division. It'd be really hard for me to write that here because there are a lot of different ways to say this. Um, but this is something we went over in class, and I hope it's still fresh in your mind. But if you need help, look on page 30, and they'll give you kind of like a chart of words that you can use to understand how to translate words into expressions. Um, but that is it for section 1.4. I hope y'all are having a good day, and I'll see you next time. Bye.